Okay, let's do question 7. So this is a nice trig question. We've got to find all the values of theta in the interval between 0 and 360 degrees, for which part A says tan 2 theta equals 0.4. There's clearly no link between A and B, so I'll just go straight into A and worry about B later. So the first thing I want to do is I can see that inside the tan function, I've got a 2 theta. And that tells me I want to change this interval so that it's in terms of 2 theta. 2 theta means multiplying theta by 2, so I'm going to multiply that interval by 2. So for part A, I want 0 is less than or equal to 2 theta, because theta times 2 is just 0, and that's less than 720 degrees. So when I find my values of 2 theta, I know I want to go all the way up to 720 degrees, so I don't miss anything out. Then I can do use inverse trig to find out what 2 theta is, one value of 2 theta. And that's tan to the minus 1 of 0.4. And that gives me 21.8 degrees. I'll just round it to 1 decimal place. Now I need to consider all the other values that will come up in the range between 0 and 720. I'm just going to draw myself a trig graph to remind myself about trig. A tan graph, sorry, not trig graph. And just get in the general shape. Then there's an asymptote. Another asymptote. You can see that my drawing is by no means perfect, but it is still going to be helpful for me. I know that from this working here that 2 theta equals 21.8 degrees. And basically this line represents 2 theta. I can't. Let's just do that again. 2 theta. So that's approximately 21.8. And then this asymptote is 90. The next asymptote is 270. Now at 21.8, tan 2 theta is 0.4. And I can see that the next time that happens is over here. So I need to think about what value is that. I know that the width of the tan graph, well, its period, is 180. So there should be an asymptote there that's minus 90. That's 180. I can see actually that this interval is 180. If you think about the interval between 90 and 270, that's 180. So to find this value, I can just add on 180, which gives me 201.8. So those are our values here, 201.8, 21.8. And that is going to keep repeating every 280 degrees. 180 degrees. So my values of 2 theta are 21.8, 201.8, 381.8, 561.8. So I've just added 180 each time to find those values. If I add on 561.8 to 180, it's bigger than 720, so I don't need to include that. Then to find theta, that's 2 theta, so I just need to divide these values by 2, so that I get 10.9, 100.9, 190.9 degrees, and 280.9 degrees. And those are your values for theta. I think an important thing to notice with the tan graph is that it repeats every 180 degrees, which makes it slightly easier than working with sine and cosine, which have more than one repeat in each period. Okay, moving on to part B, we've got 2 sine theta, tan theta equals 3. And I need to find out what theta is. I think straight away I can see that I want to use the trig identities. So I'll write those down straight away to help me. So tan theta equals sine theta over cos theta. That's probably going to help me. And sine squared theta plus cos squared theta equals 1. So first thing I want to do is substitute in that sine theta over cos theta for tan theta. So I get 2 sine squared theta over cos theta equals 3. I've multiplied the sines together straight away and squared it. Now I don't want to have a function on the bottom of a fraction, so I'm going to multiply both sides by cos theta, so that I get 2 sine squared theta equals 3 cos theta. Now I've still got 2 trig functions in here. And I really just want to have one trig function, as that will allow me to find out what theta is. Now I can get rid of sine squared theta if I use this. I can rearrange that. Sine squared theta is the same as 1 minus cos squared theta. Once I substituted that in there, I will only have cos in the equation, which will be much easier to work with. So 2 1 minus cos squared theta equals 3 cos theta. And then I'll multiply out. So I get 2 minus 2 cos squared theta equals 3 cos theta. I can see that that's going to be a quadratic with cos. So I'll rearrange that so it's a quadratic equal to 0, and I get 2 cos squared theta plus 3 cos theta minus 2 equals 0. Be careful at this stage, don't mess up the negatives. Really be careful about moving the functions onto either side. And now I can just factorise this quadratic. So with a little bit of thinking, I can figure out that this factorises to 2 cos theta minus 1 and cos theta plus 2 equals 0. So cos theta equals a half. From that one, the first brackets, the second one would give me cos theta equals minus 2. But cos theta can't be bigger than 1, so that's not going to give me any solution, so I won't bother writing that down. And then I can use my calculator, or remember that theta equals 60 degrees. But I'm not done there. The question asked for all the values of theta in the interval between 0 and 360 degrees. So I've got to check that I get all the values of theta. So this is where I'm going to sketch the cos graph. All the way up to 360. So that's 360. Now that's about 60 degrees, the first solution. Then the other one will be over here, crossing there. Now what value will that take? Because of the symmetry of the cosine graph, whatever this distance is will be the same as the distance here. So I'm going to do 360, take away 60, which gives me 300 for that value. So my other solution, which I must write down, is 300 degrees. And that's it.